using it like a calculator, which we did last time, you can actually store programs, so you do not have to retype all those things. So I'm going to show you what is known as scripts or functions, where you can store programs and reuse them as you want. This is really good if you it's probably the best way to keep track of your programs is to write a script and use it instead of trying to write down commands in the command window, which is what I showed you last time. So in order to do this, what you do is you say new script, and you can see that it's padded now. The command window has moved here, so you can still use it for calculations, but you can also write your script over here. So this is you could write a program and then execute the program. And so let's just get started. So I'm going to show you the same program. We did plot of sine x. You can write a script for that. So x equals linspace 0 2 times pi, y equals sine of x, and then plot x comma y. Okay, let's make it with the red color. So this is saying that we want the plot to have a red color indicated with the R, and then x means you'll have x's in it. So once you write that down, you can say save, or you can try to execute it, run. When you try to execute it, it asks you to save the script file. It won't let you execute it unless you save it. So I'm going to save it in my robotics folder. Okay, let's call it test1.m. So it saves and then executes. Change folder, say yes, and that is plot of sine x. Okay, so that was pretty simple. It was just copy pasting what we wrote there. Now the good thing is you can just keep running this as you want. What I like to do is, before I start any program, I like to put clear CLC and clear all, and I do close all. And what this does is this clears. You can see that I put a comment by putting the percentage sign. That is treated as a comment. It is not run by MATLAB. This clears all variables, and that one closes all figures. So we can run this again, and the code identical. It just cleared off the command window. Okay, so the good thing is now you can do other things, like let's say if you want to plot cosine, you just change this to cosine, run that, and you have cosine. Cosine starts at x equals 0, cosine is 1, so it's the point over there, so that is cosine. If you want to do the parabola, which is x square, right, when you run this, there's an error. So it's saying error using the raised to sign. Input supposed to be scalar in a square matrix. It says use power. So here's the power of MATLAB, which is I did an error, and it actually tells me how to fix the error. Okay, so I'm going to change that and do exactly what it says. The reason why this did not work is because you can't just multiply. X is see what x is. If you want to see what x is, you type x. See that it is a vector. It has 100 columns in a single row. Or if you want to see the size, just to size x 1 by 100. If you cannot multiply, if you do 100 times 1, 100, that's incompatible, right? And so that doesn't work. So what you need to do is you need to put what that does is it does component wise multiplication. So you'll take the first entry of x, multiply the first entry. So x, the first vector in x, that is just a string of vectors, first one, multiply, put it in the first element of y, do that for the second, and so on. So if you run this now, it should work all fine. That's the parabola. Okay, so really the point is just play with it. It will tell you, MATLAB will complain, it'll tell you, give you suggestions. If you're, it's always good to play with it rather than trying to solve, think of the, I just try to do things, and as things break, I fix them, and that's how I program. And people have other ways to do it. I like to do it that way. Okay, so let's move on to something slightly more complicated than this. Let's say if we have a vector like this, 1, 1, 3, 4. Okay, and we want to write a function which would add the elements of the vector. So we want to add 1 plus 1 plus 3 plus 4. So 4 plus 3, 7 plus 8, 9. So it's, sum should be 9. How do you do that? So what I'm going to do is I'm going to write a new function. So go new script. Okay. So again, I like to do CLC and clear all. I do not need to do close all because there's no figures in this particular example. Let me write A, which is 1, 1, 3, 4. Okay. And since I want to sum the elements, and this is a standard trick used when you want to keep track of the sum, you want to create a variable called total sum, which will keep a track of the sum, the cumulative sum. I want to go through all the elements. So what I do is I write a for loop, length of A. So this loop goes from 1 to length of A. Length of A is 4 because there are 4 elements. So I do total sum equals total sum plus element I. So it runs through that loop, goes from I equals 1 all the way to 4. You need to put an end to say that the for loop ends. And then if you want to print, you could just say total sum like this. It will display it, or you could, if you want to be a little bit more fancier, you can put this. Okay, so if I run this, my prediction is I will get the sum of the elements of this. That will be 9. So run. Before that, it asks me to save test2.m. So that's 9. So if you had not put total sum, you just put total sum, it would actually give you the, it'll say total sum equals 9. But since I do not want to show that, I put this when it just shows 9. Okay, so if you comment this out again, it will not be shown. So I like to, instead of deleting things, you just comment it out. That way you can save your code. Like in this case, there were 2 instances I could use total sum. I just commented one out so it doesn't run that, but I can remember what I had written down. Okay, so this is trying to find the sum of A. Now, one question is, what if I had to find, you had a different matrix, let's say B, and it has a bunch of elements, maybe 9 elements, or C, which had 10 elements. Do you have to keep writing this program again and again? So instead of doing that, what you do is you make a function which by default gives you the sum of whatever element whatever vector you input. So what I would do, rather, instead of rewriting this code again and again for different A's, B's, C's, I would just write a function called mySum, which will take input as the vector A or B or C and produce the sum. So let's do just that. And this will be just a copy paste of this code. Let's take this, copy, new script. And there's a specific syntax for this. When I write a function, I would never write CLC clear all because it clears out all variables, and I don't want that to happen. So I'll write function total sum equals my sum. My sum here is the name of the function. A is its input, and I want to get rid of this A because I want it to take any A. Could be 1 by 10, 1 by 5, and so on. So I think that's about it. Save. Now what I recommend is you want to save it as the same. It recommends saving it as mySum, and you want to save it as mySum, because if you don't do that, then you'll get an error. So by default, the function is saved as with its own name, mySum. So save. And what you can do now is you have 2 options. You could either invoke this function from the command window, which I'm going to do right now. So A equals, let's check A is that, the same thing what I wrote down earlier, and I could invoke my sum, and my answer should be 9. So that came because it used the function mySum. So when you see MATLAB having the function rand or ones, somebody has written this function ones and rand and so on. So that way you can reuse that function. Okay, now what if I've had something else? Like so, if I want to find the sum, okay, that sum is 19. Now, you could actually use the command window, or what I suggest is you can make another file, and that file calls my function. So what I'll do is I'll create a new script, and this function is going to be by itself. So it's going to call the other function. So I put CLC clear all. Let me define A, B, whatever I had written down earlier, 1, 3, 4, 5, 6. If you want, you can put more. Whatever size you want, no problem. And now you can say my sum A, my sum B, my sum C, and run this. And so it asks you to save. So let's call it test3.m. And then it runs and it tells you the sum of all. So 9 was, my sum A gives 9, my sum B gives 19, what we saw earlier, and then the third one is 11. So type C once 11 times. Okay, so this way you saved everything, and it's very easy to change things. You can easily change A, B, C, and get the sum. So that's really the advantage of MATLAB. You can write functions and keep track of your stuff by writing functions instead of trying to write everything in the command window. So it goes beyond. If you have some quick things to do, you can use the calculator, but otherwise I highly recommend using scripts. Now, as I said, do not write your own function unless you're sure that MATLAB does not have a function which you defined. So turns out that my sum was, I didn't have to write it. There is a function called sum in MATLAB which will do what I did. So if you write sum, help sum, so there is a function called sum which does sum of the elements of the vector x. So I didn't have to do what I did. I could have just done something like this: a equals 1, 1, 3, 4, and then you sum. That should give me 9. Okay, so that was wasted effort in a way because there was a function sum. So always try to see if MATLAB has something available before you write the code. In this case, I was just trying to show you how to write a function. So any questions on this? Okay. So by the way, I'm recording this, so you can go this slowly, pause my video, and then do it yourself, because I'm crunched for time to go a little fast. Okay. Okay. So next thing is animation. So you can do very nice animations in MATLAB. And did you guys ever learn this in numerical methods? No. So you could do. I do a lot of animations in MATLAB, and you could make the basic building blocks are points. That's what I showed you when I drew those crosses. Those are actually points shown as crosses or squares. But you could draw lines. There's a command called line. And actually, the more generic, the more useful one is called a patch. So if you define, for example, the corners of a triangle, it'll actually draw the triangle and fill it up with whatever color you want. So what I'm going to do is I'm going to show you simple animations first, and then I'll show you a face which I animated, and then your homework will remind you to modify that code and do a face yourself. So what we'll do is I'm going to do animation where it's basically, instead of drawing, so I drew the sine curve, I'll show you that I can actually go plotting the sine curve and make it look like an animation. And the trick is basically a for loop which runs, and you just go plot, 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 plot. And if between two plots, you pause. So it looks like a code. So think of it like a flip book. If you draw different figures and you flip the book, then you can see it. You can see an animation because of the speed. So here is a simple example showing how to do animation. So CLC, clear all. Since I'll be doing a figure, I'll do close all. Okay, so let's first get sine in place. So 0, 2 times pi, y equals sine of x. And you see that I'll try to do this incrementally. Okay, instead of trying to do everything in one shot, I will first do plot sine x, then I will do the animation. So let's do plot x comma y and run this. Okay, there we got x comma y. So my goal is to make a dot move along the sine curve and make it look like an animation. Okay, so for I equals 1 to length of x, because x defines those points. I'm going to say plot x I y I, and let's say we want to put a red circle. So what this does is it put points there, but we want to make it look like an animation. So we put a pause command, 0, 1. So it'll pause between two plots. It'll pause for 0, 1 seconds. Now 0, 1 seconds is different from my computer because it has a different clock speed compared to yours. So you'll have to play with the pause command to make it look realistic. So let's see how that will go. Okay, it's a mess. What's wrong? Well, I wanted to keep the plot x comma y before I do the dot. So what I need to do is so when it does a plot and when I redo the new plot, it erases everything which was there previously. So a simple fix to that is just say hold on. What that command does is once it does plot x comma y, it holds onto the screen, and that hold on remains as a hold on till I say hold off. So do this and run. Now it should be much better. That looked very fast. So let's increase the pause so it'll look much slower. Okay. Okay, so well, maybe I do not want the red dots to stay. I want them to go away, right? I just want to show the dot, but the previous dots I don't want to show them. So here is how to do that. What I'm going to do is I'm going to draw a green dot. I'll put the green dot right in the well, let me just do the red dot and then I can do the green dot. So what I'm going to do is I'm going to modify this so that the red dot just the previous ones disappear. Only one dot is seen corresponding to the front end of the sine curve. So what I have to do in that case is I have a hold on. I want to keep the blue line. I want to erase the red line. So I create a variable h which saves the plot x comma y. So that keeps track of the red dot. And then I want to erase that. So I say delete h. So what it does, it will plot the dot. There'll be a pause. So it'll look like it's there. And the next it'll delete it. And the next time it'll plot slightly the same red dot, but slightly moved a little bit to the right. So let's see how that goes. Now the red ones disappear. But we also were able to keep the blue lines by just doing delete. We just deleted the red dot, which shows up once. So you could do something like this. Let's keep this. Let's do a green dot x I y I green so it's the face color is green. It won't be transparent, and this is the one which I want to plot and erase. So okay, I might have got this syntax wrong. Let's see if it complains. There it is. So now it's showing the red one, but the green dot is the one which is moving forward, and its face is filled with the green color. Okay. Okay, so that was a simple example showing how to use plot to do animation. Okay, there is a command called line. You say help line, tells you how to use it. There's a command called patch, the command called text. That one will put text wherever you want to put text. Okay, so let me get to, so I wrote the face animation offline. Let me open it and explain it to you. Open, and you will modify this, or you can write your own one for the homework, which I'll post today. Okay, so let's see what the animate face does. So what's in there? Well, there's circles, right? The big circle. There's a circle for the eye, left, right. There's a circle for the eye, the actual eyes. The nose is a triangle, and then there is a half circle or a semicircle for the face. Well, how do you do that? Well, first of all, you write variables which make sense. So, for example, face, I have 5 cosine, 5 sine. So that is saying that the face, you can see that this is the big circle is a circle of radius 5. If this is 0, 0, that's 5. And so one way to understand this code is to debug it is, here's what I would do. The main, well, there's a bunch of things to define: the left eye, left eye inside, and then the right eye, which is the eyeball, and then right eye inside, the blue thing inside, and then the nose. Okay, so the nose is basically, for a triangle, you have 3 points which define the vertices of the triangle. So this defines the x vertices, so it's basically x. So there's a triangle, 1, 2, 3, and 4. So you have to define you don't need to define the starting point again. In this case, I've defined it again, but it's okay if you define the x vertices of the triangles. That's in the first line, and the y. The mouth is a semicircle, theta half. If you see this theta half, that is taking theta from 0 to pi, not 2 pi. Theta half is linspace, so it's only going 1/2, not the full 2 pi. And okay, the smile. Okay, so what I'm going to do is, one way to do this and understand this code is to comment out things which you don't understand. So let's comment out everything but comment okay, that's the circle. So what happened here was the for loop, which is my main loop which does animation, I only kept the plot. So that's what came from that. So now let's get rid of the left eye, right eye. So that's what it did. And so this is how you can understand the code. It's by breaking it down. So patch I've not introduced. Patch is something which would not only put, so the plot would only draw the outside. The patch command will actually draw the circle and also draw, fill it up with the colors. In this case, I filled it up with K, which is black. Okay, so this was patch for the nose. Okay, then this smile. Okay, and then okay, I wanted to debug this command again. You can play with this. Uncomment. Control T. Okay, you should play with this to understand this. Let me not explain this to you, but what it will do is it basically opens the mouth sometimes like that, and then okay, and so that's the complete animation. Now for the homework, you'll have to submit, I think you have to send me the video of this. So it turns out that MATLAB has a way in which you can save the animation as a video, and this part of the code is already inbuilt in this. What I did was I wrote a bunch of commands which would save the file as a video. You just have to say write movie 1 instead of 0, so it will actually output a video. Right now, in my script, this is a place where I put all the files. There's no video. I'm going to run this with write movie equals 1, and you can read the code. What it does actually, it takes the frame, each frame, each time I do plot, and just puts it together just like the flip book, and then makes it into a video. Run this. So it'll run it first, and it's a little bit slower because it's actually saving the frames. So you'll write an AVI file, I believe, and then you can use one way to convert files easily is if you have a YouTube account, you can upload it and then download it as an MP4. And there are other ways to do it too. Okay, done. Let's see the file. Should be, there it is. Face. So it saved that. So you do not have to do, people do screen, you don't have to do screen recording. It actually will save the file you want, the way you want to save it. "50 students in the class, and each of them made a face, and I just compiled everything together." So some of them made pretty complex faces, pretty impressive. So you'll do this for your homework. I'll post the homework today. That was a fancy one. By the way, you can put whatever color you want. You're not limited to red, green, blue. If you know RGB, red, green, blue, the command, you can actually change. Instead of putting red, you can put 100 and it'll take it as red. But if you put 111, it'll be a different color. It'll be black, right? You can put 0.5, 0.5, 0.5. So let me show it to you. So that way you can make more better. So what I'm saying is that if you go here, and if you want to put some fancy color, let's say to some color which is not the standard colors, right? If you want the face to have, the tongue to have not a red color, then let's say 0.5, 0.5, 0.5, and I don't know what that color is. You run this. That's a gray color. Let me kill. Hold on, I just remove the video off. So what I normally do is if I want a specific color, so it's 255, 192, 203. Okay, so that's what I want. Well, okay. So MATLAB will not take 255. It actually takes a number from 0 to 1. So you have to convert the number from 255 to 1. Well, 255 is the max. So 255 divided by 255, 1. 1 is the 255 corresponds to 1. So what you would do is you go to MATLAB and you would paste it here. and you divide the whole thing by 255 because it only accepts a number from 0 to 1. So my claim is now that the mouth, the tongue, will be pink. See? Yes. So you can make it